Not only do moving charges create magnetic fields, a magnetic field can also exert a magnetic force on moving charges. So what are the requirements for a charged particle to feel a magnetic force? Well, first of all, the particle does have to be charged. So it has to have a certain charge Q that is non-zero. We also have to have a particle that is moving. So it has to have a certain non-zero speed, v. The particle must also be moving through a magnetic field, B. However, even a moving charge in a magnetic field might not feel a magnetic force. This happens if the charge is moving exactly in the direction of the magnetic field or 180 degrees opposite to the magnetic field. Let's look at these examples here and try to determine which particles will feel a magnetic force. You can go ahead and make your guesses, and then I'll give my answers. In every case, our magnetic field is directed to the right. This is a particle that's stationary. Now, even though it has a q, which is non-zero, we see that the speed is 0. With that in mind, the magnetic force will be 0. So this is different from what we saw with electric fields and electric forces. When it came to electric forces, a charged particle simply being in an electric field would cause it to feel an electric force. But when it comes to magnetism, the particle in the magnetic field here does not feel a magnetic force. Now the letters that we'll use for this will be F with a subscript of B. That would be the magnetic force. And we'll say that it's 0 in this case. What about if our positive charge is moving in the direction of the field? Will it feel a magnetic force then? No, it won't. Once again, the magnetic force will be 0 in this case, but for a different reason. The reason is that the velocity vector is parallel to the magnetic field vectors. And when that happens, there won't be a magnetic force. What about if we have a negatively charged particle moving perpendicularly through a magnetic field? Will there be a magnetic force? There will be. The reason is that the particle has charge q, it has velocity v, and it's moving perpendicularly through a magnetic field B. How about our positive charge that's moving against the field? Will there be a magnetic force then? No. The idea is that the particle has to be moving across field lines, not with them or against them. What if our particle is moving into the page? Would that count? Would there be a magnetic force in that case? There actually would be. Because if we're moving in the negative z direction, our velocity vector is in the negative k hat direction. Our b is in the positive I hat direction. And we see that I hat and negative k hat would definitely be 90 degrees perpendicular to each other. But what if we have a neutral particle, a neutron, let's say, and it's moving out of the page? Well, in that case, even though the direction of the magnetic field is to the right and the velocity direction of the particle is out of the page, I hat and k hat are perpendicular. The only problem with this situation, though, is that Q is 0. So for that reason, there will be no magnetic force. Let's try these ones now. Take a look at the situations and see if you can answer whether there would be a magnetic force, and if not, why not? All right, here our negatively charged particle is stationary, which means its speed is 0. So therefore, the magnetic force is 0. Here, the velocity direction is in the positive I hat direction. The magnetic field direction is actually into the page, so that would be negative k hat. Negative k hat is definitely 90 degrees perpendicular to I hat. So yes, there would be a magnetic force in this case. Here we see that the velocity of our particle is in the positive j hat direction. It's moving up, and according to the given coordinate system, up was positive y. We also see that the b is into the page. Negative k hat and j hat are 90 degrees perpendicular because they're in different dimensions. One's in the y dimension, the other one's in the negative z dimension. So yes, we'll have a magnetic force here. All right, here our velocity is in the negative I direction, but our b is negative k hat, so yes, we will have a magnetic force here. Here our positive charge is moving into the page. All right, so what direction is that? Negative k hat, right? But we see that the b here is also negative k hat. That's a problem. When the velocity of the particle is in the same direction as the magnetic field lines, then there will not be a magnetic force here. And we have a neutron moving out of the page. That would make the v in the k direction, and the b is in the negative k direction. Those are anti-parallel, so just from that information alone, there wouldn't be a magnetic force. But additionally, we see that Q is again 0, so there will definitely be no magnetic force here.